Today we discuss one of the important name reaction known as Michael addition or Michael reaction. The Michael reaction is the one of the important reaction of the formation of carbon-carbon bond. Michael reaction or Michael addition is the nucleophilic addition of carbonyl or another nucleophile to an alpha-beta unsaturated carbonyl compounds containing an electron withdrawing group. Michael addition reaction may be defined as the addition of active methylene compound to the double bond of alpha-beta unsaturated compounds or nitriles in the presence of an basic catalyst to give addition product is known as Michael adduct. The alpha-beta unsaturated compound or nitriles in this reaction are known as Michael acceptor, whereas active methylene compounds are known as Michael donor. In Michael addition reaction, the active methylene compounds like malonic ester, acetoacetic ester, cyanoacetic ester, acetyl acetone, etc. can be used. The next question is arising in our mind that what is meant by active methylene compound. So methylene compound are the compound that containing the methylene group, that is CH2 group. When two strong electron withdrawing group attached to your methylene group, then the hydrogen atoms which are present on the methylene group are strongly acidic in nature, and therefore if such compound when treated with mild bases, they easily ionized and to produce the carbonyl. Then this resultant carbonyl is well stabilized by the resonance of electron withdrawing group that attached to that methylene carbonate. In Michael addition reaction, such carbonyl attack on the beta carbon atom of alpha beta unsaturated compound to give addition product. Generally, this reaction is an example of 1,4 addition reaction, but we observe the product is the 1,2 addition product, or there is addition of active methylene compound on the alpha beta bond, where the hydrogen atom of active methylene group bound is attached to the alpha carbon atom, whereas remaining group of the active methylene compound is attached to the beta carbon atom. So we can say that this is an example of addition of active methylene compound on carbon-carbon double bond of alpha-beta unsaturated compound. In Michael addition reaction, we can observe that there is addition of active methylene compound on the carbon-carbon double bond of alpha-beta unsaturated compound in such a way that one of the hydrogen atom of active methylene group is attached to the alpha carbon atom, whereas remaining active methyl group is attached to the beta carbon atom. This can be well explained with the help of the following example. For example, the malonic ester having the active methylene group when react with the acrolein, that is the alpha beta unsaturated aldehyde, in presence of weak base, that is NN diethyl ethylamine in ethanol. So we observe that one of the hydrogen atom of malonic ester is attached to the alpha carbon atom, whereas remaining active methylene group is attached to the beta carbon atom to give the addition reaction. Another example is the addition of cyanoacetic acid on ethyl cinamid. So again we can observe that one of the hydrogen atom of active methyl group is attached to the alpha carbon atom, whereas remaining part of the cyanoacetic acid is attached to the beta carbon atom. And therefore we can easily understand that in Michael addition reaction, the one hydrogen atom from active methylene group is attached to the alpha carbon atom, whereas remaining part of the active methylene compound is attached to the beta carbon atom. Conditions for Michael addition reaction. Weak organic bases are used. If you use the strong bases like ethoxides, Then ethoxide causes side reactions like cyclization. The second condition is that in this reaction, base is act as the catalyst. Therefore, the bases are regenerated during the course of reaction. Hence, small amount of the weak base is sufficient. Excess of active methylene compound is used to prevent the either side reactions. Generally, such reactions are carried out at lower temperature, near about 25 degrees Celsius, and the protic solvent is favor this reaction. Therefore, alcohol is used as the solvent, which reduces the reaction time of the reaction. Mechanism of Michael addition or Michael reaction. For discussing the mechanism of Michael addition reaction, here we discuss the reaction between the malonic ester with acrolein in presence of weak base in ethanol. Generally, Michael addition reaction take place in the two steps. First step is the formation of inuletine. So malonic ester is an example of active methylene compound. In this active methylene compound, the methyl group, that is denoted by alpha carbon atom, has two hydrogen atoms, and these two hydrogen atoms are acidic in nature. Therefore, when the malonic ester is react with the base, the acid base type of reaction will be takes place. The weak base having the lone pair of electron, and this weak base abstract the one of the hydrogen atom of alpha carbon atom, or we can say that the active methylene compound lose alpha hydrogen atom in presence of weak base to formation of carbon. So this carbanion is the conjugate base, whereas the base which abstract the alpha hydrogen atom, which is the protonated, act as the conjugate acid. This carbanion or conjugate base, in which the lone pair present on the carbon atom is in conjugate with the carbonyl group of ester, and therefore they show the resonating structure to formation of inuletine. Then this negative charge on the carbon atom form carbon-carbon double bond, and the carbon-oxygen bond will be open, and bonding pair of electron is going with oxygen to formation of inuletine. This inuletine is stabilized by the another resonating structure. So again, the negative charge oxygen atom donate the lone pair of electron. Therefore, this carbon-carbon double bond, it to form another carbon-carbon double bond, and another of get the negative charge to formation of another inuletine. So in this way, the negative charge on this carbanion is shared by the three carbon atoms, and therefore this carbanion is highly stable. Second step is nucleophilic addition. Generally, in case of alpha beta unsaturated carbonyl compound, in which the carbon-carbon double bond is conjugate with the carbonyl group, and therefore the alpha beta unsaturated carbonyl compound shows the another resonating structure. In this resonating structure, beta carbon atom gets the positive charge and oxygen atom gets the negative charge. If we draw the resonating hybrid structure of this alpha beta unsaturated compound, we observe that the beta carbon atom is more electron deficient than the carbonyl carbon, and hence your nucleophile, that inuletine or carbanion, attack on the beta carbon atom instead of the carbon of carbonyl group. Therefore, there is the nucleophilic addition of carbanion or inulate ion to the alpha beta unsaturated double bond, and the product is protonated to give the enol, which changes into the keto form of the product. Therefore, beta carbon atom is more electron deficient than the carbonyl carbon of the carbonyl group, and therefore the nucleophile that is carbon ion, attack on the beta carbon atom of alpha beta unsaturated compound to gives addition product. Okay, so here the enolate ion attack on the beta carbon atom through the carbon atom, and due to this alpha beta double bond will be break and new bond between the carbonyl carbon and alpha carbon will be formed with the oxygen get the negative charge. Then this negatively charged oxygen atom abstract the proton from the conjugate acid and your base is regenerated. Then there is the formation of enol compound, and then this enol compound undergo the keto-enol tautomerism to gives your final product, that is the Michael adduct. Applications of Michael reaction. First application, synthesis of dicarboxylic acid. When the Michael addition reaction is carried out between two esters and the product on hydrolysis followed by the decarboxylation gives a dicarboxylic acid. For example, synthesis of beta-phenyl glutaric acid. When malonic ester is react with ethyl 3-phenyl propanoate in basic condition, Michael addition reaction will be takes place. So addition reaction take place in a such a way that the one of the hydrogen atom of malonic ester attached to the alpha carbon atom, whereas a remaining group of malonic ester attached to the beta carbon atom to gives Michael adduct. So this Michael adduct having 3 ester groups. Then this Michael adduct undergo the alkaline hydrolysis, ester group undergo the hydrolysis and convert into the corresponding carboxylic salt. Then this carboxylic salt when undergo the acidic hydrolysis, then this carboxylate ion abstract the proton from the solvent to formation of carboxylic acids, and then this tricarboxylic acid when heating with soda lime undergo the decarboxylation, the one of the carboxylic group undergo the decarboxylation gives corresponding dicarboxylic acid is known as beta-phenyl glutaric acid. Second application of Michael reaction is synthesis of tricarboxylic acid. For example, when diethyl malonate or cyanoacetic ester are react under the basic condition to gives Michael adduct, and which on hydrolysis followed by the decarboxylation gives propane 1,2,3 tricarboxylic acid. The another application of Michael reaction is synthesis of keto acid. So when alpha beta unsaturated ketones react with active methylene ester gives Michael adduct, and which on hydrolysis and decarboxylation gives keto carboxylic acid. For example, synthesis of 5-keto hexanoic acid. So when methyl phenyl ketone is react with malonic ester in presence of weak base gives Michael adduct. Then this Michael adduct first undergo the alkaline hydrolysis, then followed by the acidic hydrolysis gives corresponding dicarboxylic acid, and then this dicarboxylic acid heating with soda lime undergo the decarboxylation to gives 5-keto hexanoic acid. The another application is synthesis of diketones. So when alpha beta unsaturated ketones react with acetoacetic ester to prepare diketone. For example, synthesis of 2,6-heptane di-1. So when methyl phenyl ketone are react with acetoacetic ester in mild basic condition to gives Michael addition product, and then Again, this Michael addition product undergo the alkaline hydrolysis followed by acidic hydrolysis gives carboxylic acid, and then when this carboxylic acid is heating with soda lime undergo the decarboxylation gives 2,6-heptane dione. Michael addition reaction is also applicable for synthesis of diamidone. Diamidone is a special reagent which can be used to detect aldehyde group even in the presence of a ketone. So such diamidone reagent can be prepared with the help of the Michael addition reaction followed by the intramolecular Claisen condensation reaction. So in this reaction, methyl oxide react with the malonic ester in presence of base gives Michael adduct, and then this Michael adduct which treated with sodium ethoxide undergo the intramolecular Claisen condensation reaction to form cyclic compound, and then this product which on alkaline hydrolysis followed by acidic hydrolysis and then followed by the decarboxylation, diamidone will be formed.